Buried beneath Cambodia's ancient earth lies a truth far older than the temples of Angkor. A truth not carved in stone, but written in blood. One that slept for 2,000 years in the silent bones of a child. He was no more than 5 years old. Buried in the vast cemetery of Wat Kamnu, near the banks of the Mekong River. His grave held beads, pig skulls, and ceramics, relics of a society on the edge of statehood. But what he carried inside him was far more valuable, because when his DNA was finally decoded, it revealed something no archaeologist, no historian, had ever expected to find. Almost half of his ancestry, 42 to 49%, traced not to East Asia, nor to ancient foragers of Southeast Asia, but to the distant shores of southern India. This wasn't a trick of the data, not a contamination. It was undeniable. This child was the genetic offspring of two worlds, a fusion of deeply local ancestry and unmistakably South Indian blood. But how could that be? For decades, historians believed that India's influence in Southeast Asia was cultural, temples, trade, script, and that it arrived slowly, gradually, beginning perhaps in the 4th century CE. But this child was buried a full 300 years earlier, and yet, his genome told a story no text could record. He wasn't an isolated case of contact. He was proof of something more profound, that the genetic bridge between South Asia and Southeast Asia was already in place by the 1st or 2nd century CE, that long before the rise of Angkor, or the spread of Sanskrit inscriptions, there were people, living, breathing people, who were the living embodiment of a merger between two ancient civilizations. And the implications don't stop there, because when scientists look deeper, not at one child, but at the broader DNA landscape of Cambodia, what they found was even more astonishing. Lineages so old, they stretch back to the very first waves of human migration out of Africa. Mitochondrial haplogroups found in Cambodia's highland tribes with coalescence ages of 55, 000, 60, 000, even 68,000 years. These aren't minor subtypes. They are basal branches, genetic fossils, traces of humanity's earliest steps into Southeast Asia, preserved not in museum cases, but in the living people of Cambodia. And then comes the convergence. A child of southern Indian and local ancestry, buried during the era of Funan, the same kingdom that Chinese sources say was founded by an Indian Brahmin named Kondinya and a local princess named Soma. A genetic match to the legend? Or coincidence? We can't say for sure, but the overlap is striking. The child's genome matched best not with northern Indians or Persians, not with traders from Bengal or Gujarat, but with populations from the deep south, the irregular, the Velular, the Mala, Dravidian-speaking groups from the Tamil heartland. In this light, Funan doesn't just look like a cultural hybrid. It looks like a biological one. And the boy in the grave, ABM 40/I-1680, wasn't just a member of a forgotten kingdom. He was a witness, a bridge, living evidence that the foundations of Cambodian civilization were shaped not only by trade and ideas, but by intermarriage, migration, and bloodlines stretching across the Bay of Bengal. What else, then, lies buried? What other graves whisper stories that history books have missed? The soil remembers, and DNA does not lie. The temples of Cambodia rise in silence, but their foundations are rooted in something far older than stone. For years, scholars thought the great shift in Southeast Asian civilization came with ideas, trade, writing, architecture. But what if the transformation began not with words, but with genes? In the shadows of the Mekong Delta, geneticists uncovered a mystery buried in plain sight. A single child, unearthed from the ancient cemetery of Wat Kamnu, revealed a story so unexpected it shattered the timeline of Southeast Asian history. He wasn't just a local boy. His genome lit up with signals from another land, southern India. Not faint traces, not diluted whispers of trade. A full 49% of his DNA mapped directly to Dravidian populations who, even today, live thousands of kilometers away. But the real question isn't where that DNA came from. It's when and why. Because his burial predates the Grand Temples, predates Angkor, predates even the earliest written Khmer inscriptions. He lived during the dawn of Funan, the first great kingdom to emerge in what is now Cambodia. a kingdom historians believed was inspired by Indian influence. But no one imagined that influence ran through the bloodstream. This wasn't a trickle of contact. It was a wave of ancestry. Modern Cambodians carry around 12 to 15% South Asian DNA. But this child, he carried nearly half. That single genome rewinds the clock 1,000 years further back than previously believed. It forces us to rethink everything: the origin of state formation, the depth of cultural exchange, and the speed at which entire identities can shift. And the match wasn't vague. It wasn't Northern India, or Central Asia, or Persia. The closest genetic affinities came from southernmost India, groups like the irregular and velular, ancient communities tied to the very roots of Tamil civilization. So how did that bloodline reach Funan? The archaeological clues were already whispering. Beads of carnelian, traced to Indian mines. Rice strains not native to Cambodia. Architectural forms eerily similar to South Indian prototypes. But until now, the link had always been seen as symbolic, cultural emulation, not biological entanglement. Now, the child's DNA says otherwise. It tells us there were people, not just ideas, moving across oceans, settling, intermarrying, creating new societies that were neither purely Khmer nor purely Indian, but something entirely hybrid, a living blend of Southeast Asia and the subcontinent. What kind of society could emerge from such a fusion? A kingdom like Funan, described by Chinese envoys as powerful, literate, and cosmopolitan. A society where Hinduism took root, not as a distant import, but perhaps as a faith carried in the hearts of Indian settlers themselves, where the line between foreign and local was already dissolving, not just in palaces and ports, but in the marrow of its people. This child wasn't a fluke. He was a signpost, a genetic lighthouse standing at the intersection of two great civilizations. And the question that lingers isn't just how early this began, it's how far it reached. Were there others like him? Other children of Indian and Khmer ancestry, growing up in the early streets of Funan? If we dig deeper, do we find more hybrid genomes? Or was he part of a royal bloodline, a dynasty born from union, not conquest? The ground beneath Cambodia is still holding its secrets. But one thing is certain: the story of Southeast Asia was never one-sided. It wasn't a passive reception of culture. It was a merging, a collision, a birth of something new. And it didn't begin in temples. It began in the bones. Funan wasn't carved overnight. It rose from something more intimate than warfare, from interwoven lives, shared bloodlines, and generations of merging traditions. When archaeologists unearthed Wat Kamnu, they expected pottery, bones, and burial goods. What they didn't expect was a complete rewrite of how Southeast Asian civilization began. Because inside that cemetery, amidst ceramics and pig skulls, they found an entire genetic blueprint that defied historical consensus. It wasn't just one child with South Indian ancestry. It was the possibility of many. A population shaped not by conquest, but by the quiet force of intermarriage. People who didn't just adopt Indian culture, they inherited it through the bloodstream. And this changes everything. For decades, scholars believed Indian influence in Cambodia was ideological, a borrowed script, a mimic religion, a series of political gestures aimed at prestige. But DNA tells a different story, one where genetic inheritance and state formation happened side by side. The foundations of Funan weren't laid in silence. They were whispered between families. A South Indian settler and a Khmer partner. A child born of two continents. A dynasty that grew not from war, but from union. And we're not talking about hypothetical admixture. The data is precise. The genetic models don't just hint, they quantify. Between 42 and 49% South Asian ancestry in the ancient child's genome. Not a symbolic fraction. A near-equal division. A genetic duality. And yet, by the time we look at modern Cambodians, that proportion shrinks. Down to 12, maybe 15%. What happened? It suggests that these early South Asian lineages were once strong, central, even in certain regions, in certain communities. But as centuries passed, as new populations arrived, and internal mixing continued, the genetic signal diluted, leaving only traces. Still, those traces are not invisible. They remain, tucked inside modern Khmer DNA, like echoes of forgotten kingdom. This is where history and biology meet. We've long known that Funan was a powerful trade hub, rich in goods and cross-cultural exchange. But what this DNA confirms is that those ships didn't just bring spices and scripts. They brought people, settlers, artisans, spiritual leaders, who stayed, lived, and reshaped the local identity from within. You can see it in the artifacts. Beads from Gujarat, architecture that mirrors Tamil temples, rituals with Vedic fingerprints. But now, we know those were more than cultural artifacts. They were expressions of a mixed society, one where Cambodian and Indian heritage coexisted in a single body. And when we revisit the Chinese chronicles that describe Funan's founding, the tale of Condinya and Soma, it no longer feels like legend. It feels like memory, a poetic retelling of a real phenomenon. South Asians integrating into Khmer society so deeply, they helped forge its earliest kingdom. Funan wasn't a colony. It wasn't a satellite. It was something new, a biological and cultural hybrid, born of migration, rooted in marriage, and passed down through both blood and tradition. It's not the history we were taught, but it may be the one that actually happened. Because while stones can crumble and stories can fade, the human genome remembers. And in Cambodia's case, it remembers everything. High in the forested hills of northeastern Cambodia, far from the tourist trails and royal ruins, live the descendants of a genetic legacy older than kings, older than kingdoms, older than history itself. These are the highland tribes, the Breo, the Jarai, the Krung. Their villages appear quiet, but their DNA, it roars. When scientists began sequencing the maternal lineages of these indigenous communities, they weren't expecting to uncover a hidden archive of human evolution. Yet that's exactly what they found. Mitochondrial DNA, passed down from mother to child for tens of thousands of years, revealed something astonishing. At least 8 previously undocumented genetic branches. Not variants, not subtypes. Entire haplogroups, ancient, undisturbed, and basal to the Asian genetic tree. Lineages like M78, N7, and M59. Each one a living fossil, with coalescence ages pushing back beyond 60,000 years. These aren't echoes of Indian influence. They're deeper than that. They come from a time when modern humans were just stepping out of Africa, following the salt air along the coastal fringe of South Asia, and into the uncharted jungles of mainland Southeast Asia. And unlike other regions where these early lineages were overwritten by waves of farmers and empires, Cambodia's interior preserved them. Locked in isolation, shielded by terrain, and passed on through unbroken maternal lines. These people didn't just inherit ancient genes. They are the gene flow. They are the continuity that history books missed. Even more surprising, these ancient haplogroups don't cluster neatly by language or ethnicity. Austroasiatic, Austronesian, the genetic borders blur. What that tells us is profound. These communities weren't sealed silos. They were part of a dynamic web of interaction, movement, and shared ancestry. And yet, their genetic profile remains distinct from both modern East Asians and South Asians. It's as if they stood still while the rest of Asia shifted around them. It's not just the haplogroups that are unique. It's their diversity. One study examined over 1,000 individuals from 14 Cambodian groups. The result? A maternal genetic reservoir unlike any other in the region. The frequency of ancient lineages, the depth of divergence, the basal positions, all point to one conclusion. Cambodia wasn't just a crossroads. It was a cradle. From this cradle, major mitochondrial lineages likely spread outward, northward into China, southward into the islands of Indonesia and the Pacific. But the roots? The roots remained in the highlands. And if that wasn't enough, the Bayesian skyline analysis of these populations showed something even more shocking. No evidence of a Neolithic population explosion. Unlike other regions of Asia, where farming sparked demographic booms, the highland Cambodians maintained a stable genetic signature, immune to the sweeping tides of agricultural expansion. What does that tell us? It tells us that they weren't just bypassed by history. They chose another path, a parallel evolution, untouched by the forces that reshaped much of the continent. In these people, we don't just glimpse the past, we stand inside it. Every strand of their DNA is a thread back to the dawn of modern humanity in Asia. And yet, until recently, no one was looking. While the focus stayed on the lowlands, the royal cities, the inscriptions, these ancient lineages waited quietly, unrecognized, uncelebrated, but still very much alive. Now that science has finally listened, they have begun to speak. And what they're telling us is that the story of Cambodia isn't just about Indian contact or empire building. It's about deep time. It's about survival. And it's about a people whose blood holds the memory of a world long lost. From a distance, Cambodia may seem like just another chapter in Southeast Asian history. But when you zoom into its DNA, the script begins to look entirely different, like a lost volume of human origins written in a dialect no one noticed. Because unlike its neighbors, Cambodia holds not just fragments of the past, but entire genetic signatures that don't exist anywhere else. It's not the amount of diversity that makes it exceptional, it's the kind. The presence of novel maternal haplogroups. The unusual blend of deeply rooted East Eurasian ancestry with an unexpectedly strong South Indian genetic pulse. The fact that one ancient child showed nearly half his genome tied to southern India, while modern Cambodians still carry echoes of that fusion, thousands of years later. None of this fits cleanly into existing migration models. And that's the puzzle. Every other region in Asia has a pattern. Southern China shows clear Neolithic farming expansions. The islands of Indonesia reflect Austronesian dispersals. Even Vietnam follows predictable gene flow routes from the north. But Cambodia is irregular. It's the exception, the outlier, the place where timelines tangle. You have isolated highland tribes whose maternal DNA traces directly back to humanity's earliest coastal migrations. Then suddenly, you find a protohistoric boy whose ancestry matches 21st century South Indian populations, not partially, not faintly, but with genetic clarity. Where else in the world do such extremes live side by side? This isn't just genetic variation. It's layered inheritance, stacked strata of human movement, frozen in time by geography, climate, and culture. And it gets more complex. When scientists ran principal component analyses, Cambodian populations didn't fall neatly into Southeast Asian clusters. They drifted toward India, toward the Andaman Islands, even toward genetic markers linked to ancient Australians. That shouldn't happen, but it does. It's like a genetic gravity well, pulling in signals from places thousands of kilometers apart. Is it the result of early maritime trade? A remnant of first-wave migrations out of Africa? Or something entirely unknown? A population that stayed rooted while the rest of the world shifted? Even computational models struggle here. When QPDM was used to simulate ancestry proportions, most plausible models for the ancient Cambodian child required surrogates from southern India and specific East Asian island populations, not from northern neighbors. And the model didn't work if you swapped them. That means this wasn't random. It was a defined, directional genetic exchange. So what does it all mean? It means that Cambodia isn't just a case study in Southeast Asian genetics. It's a keystone, a place where the threads of prehistory tie together in ways we're only beginning to understand. The deeper we go, the more questions emerge. Why are these unique lineages still surviving in Cambodian Aboriginal groups, but extinct elsewhere? How did Southern Indian genes arrive so early and so powerfully, centuries before mainstream history acknowledges that kind of movement? Why does Cambodia retain maternal lineages that appear to predate agriculture, metallurgy, and even the rise of major civilizations? Every answer leads to another mystery. But perhaps that's what makes this story so urgent. Because Cambodia isn't just holding on to ancient DNA. It's holding on to the very mechanisms of memory that science is only now learning how to read. And if we fail to listen, if we allow these communities, these lineages, these buried signals to vanish, we don't just lose data. We lose a chance to rewrite the first chapters of human civilization. Long after empires fall and cities turn to dust, something remains. It doesn't erode like sandstone. It doesn't fade like ink. It doesn't need to be unearthed with trowels or deciphered with lexicons. It waits inside the living. Every person walking the streets of Phnom Penh or farming the hills of Ratnakiri carries within them a story far more durable than history books. A story not written in Khmer or Sanskrit, but in the silent code of nucleotides. This isn't about ancestry anymore. It's about identity, about belonging, about how ancient strangers became ancestors, and how their choices, their unions, their migrations still echo in every cell. The boy from Vat Kamnu is long gone, but the questions he left behind have only begun to speak. Why did his genes carry such a high dose of South Indian ancestry? Was he born of politics or love? Was he royalty? Or simply a child of a coastal crossing now lost to time? We may never know his name, but we know what he meant. He cracked open a door, and through it, we glimpsed a world where Cambodia wasn't just receiving influence. It was generating something new. A civilization crafted not from imitation, but from fusion. A society that didn't just borrow, it blended, redefined, and birthed something original. And it didn't stop with him. The mitochondrial lineages found in highland tribes still bear witness to migrations so ancient they defy current models. These people, often overlooked, are living monuments. Every step they take is a continuation of journeys that began 60,000 years ago. We tend to look at history as layers, one era buried beneath another. But genetics collapses time. The ancient lives inside the modern. The past lives inside you. So the next time someone says Southeast Asia was shaped by outside forces, remember this. Cambodia didn't just receive history. It made it. Not just in temples, or trade, or kingship, but in its very blood. The ground still holds more answers. There are more bones to find, more sequences to read, more forgotten names waiting to be heard again through the language of DNA. But one thing is already clear. Cambodian DNA is not a reflection of the past. It is the past, preserved, breathing, evolving, and still speaking. The question is, are we ready to listen?